Today we're starting our area volume unit, and again, this one's going to go kind of quick, just 3 days. This is why we've been reviewing some area and volume problems as we've been doing our warm-ups. So we're going to jump into some of the applications. There may be one or two new items that we need to review through our examples, but we'll check those out over our next few days. So do keep in mind your formula area or your area and volume formulas are not ones that you need to memorize. So while I do have the formulas that we're going to be using specifically today already in our organizer, don't forget you do have a formula sheet available. The same formula sheet that we're going to make available for your exam is the same one that we're going to have for our quiz as well. And you can find a link to that at the very top of our Unit 11 folder. So if you do have a printer, I would absolutely suggest printing that out. And if not, you're going to want to jot down those formulas on a separate paper that you can use for reference, so you don't have to keep opening up the same page over and over again, and you can have those out as you're working. So the first thing that we're going to look at today is actually composite figures. And what that means is we're going to be putting together multiple shapes or multiple figures to make another figure. So let's do a few problems that are just using straight out, two-dimensional flat pictures. So just straight out area. And then we'll look at a few that use three-dimensional or solid figures. So our first example that we're going to check out is the area of this wacky thing that what kind of shape does it look like it's made up of? And so it seems to me that we could go through and actually divide this up into a bunch of different rectangles. And it really depends on how you would want to set these up. But, again, it's whatever you see as how you're going to divide this up. So I see like this small little rectangle on top. And so I know that that's going to have an area. For any rectangle, I know I'm just going to do length times width. So that one's going to have an area of 2. So I'm just going to write the answer in there just for reference. Okay, and then I have another one, again, easy to kind of divide out. We have a 4 and a 2 for length and width, so I know that one's going to be an 8. So may as well divide out that smaller one. Again, going to be an 8. And we have a little one over here. That'll be a 2. And so then we're just left with that larger rectangle in the middle, and we just need to figure out what our lengths are. So we know we had, let me change my color for labels. So we know we had a 4 along this segment, the bottom of the rectangle, and we had a 1 on the bottom of this segment. So what does that mean is left over in the middle if the whole entire bottom is 9? We'll take the 9, subtract out the 4 and the 1, so subtract a 5. Well, we're going to be left with 4. Okay. Then we need to know the height of our figure. We've got this 4 here, but we also have a length 2 here from the small rectangle. So that means this entire side is 6. So that means the entire large rectangle in the middle, 6 times 4, will give us 24. And the idea with composite figures is if you know what the individual pieces are, all you have to do is add them up. And so that means, 24. And so I just need to add up 2 plus 24 plus the 8s on the sides and the extra 2 on the left. So adding those up on our trusty calculator, I'm getting 44 as my total area. And so when we're talking about area and volume, we absolutely want to use units. They didn't give us anything like inches or feet in this one, so I'm just going to say units and squared because it's area. Every single one of the figures, we had to do length times width, so we were multiplying 2 units together. All right, example 2, find the area of a kite. And there actually is a formula that we could use for this, but again, what kind of shapes do you see in here that might be helpful? Okay, so I see actually 4 triangles, but I'm going to make this a little easier on myself and actually divide it up into 2 triangles. And you could do this either way, but I'm going to divide it up along this diagonal. And here's the reason I'm going to do that. So I have my triangle on the left, which if I redraw that, see that longer or the actually shorter base is this guy from the middle. Well, that whole length is going to be 40. And the overall height, well, that's the 56. If I look at the small triangle on the right-hand side, then I have that same center piece of 40, but this one has a height of 26. And so if you look at your formula sheets, and we reviewed this in one of our warm-ups, how do we find the area of a triangle? Well, triangle area is just 1/2 base times height. So the area of my left-hand triangle will be 1/2 times 40 times 56. And so again, plugging that in the calculator gives me 1120, which again seems kind of big, but think about your numbers. You're multiplying fairly large numbers together. Okay, our right-hand triangle is going to give us 1/2 times our base 40 times our height 26. So multiplying that out, I get 520. And so my total area, I just have to add those pieces together. So that's 1120 plus 520 equals 1640. And again, no units given, so I'm going to say my units squared to keep it general. So again, just looking for pieces that we know about. So we actually have one new shape on here that I want to look at real quick. Find the area of the hexagon. So this one's a little weird, but we have a formula for this one. And as long as we have all of the variables that fit in the formula, we can still find that area. So I'm going to scroll back up. So this is the formula we're going to use for it. It's even a hexagon given here, but we could do this with any polygon. So it doesn't matter if it's a regular hexagon, a regular pentagon, octagon, dodecagon, doesn't matter. This works for any regular polygon. And so specifically what I'm going to look at is this second one is what happens, or is usually more helpful. So we have 1/2 PA. A is this little guy in the middle. He's called an apothem, but you don't really need to know that. But it does go from the center straight out to one of the middle of the sides. Then it's times that P. Well, the P stands for perimeter. So if we know all the sides around the figure, and we know that one length that goes straight to the middle of one of the sides, well, then we can find the area of that figure. So let's go back down to 3 and see if we have that. So we have our apothem. That's this guy. It's not a pretty number, but 5√3, we have a value. This piece says this side is 5 centimeters. Well, if that's a regular hexagon, what should every other side also be? Also 5. So that means, what is our perimeter going to be? Well, if we have 6 sides, each side is 5 centimeters, that means our perimeter is 30 centimeters. And so I now have enough to fill into my formula. So area equals 1/2 P times A. So 1/2, my perimeter is 30, and my apothem is 5√3. And it really depends on how the question is worded, if it wants to give you an exact answer or maybe simplified with the radical in there. But let's go ahead and just type the whole thing in the calculator. And if you are going to go all at one step, just make sure you put the √3 at the very end. And not a bad idea to put parentheses around it as you're multiplying. So I'm going to do 1/2 times 30 times 5 times the square root of 3. And I'm getting out the decimal, so approximately equal to 129.90. And they did give us units on this one, so it's centimeters squared. Again, all I did was find the formula that looked the most like it, plug in the information that I could figure out. Excuse me. Okay, example 4 is included. Technically not a composite figure that we're putting together pieces, but if we're looking for the shaded region. And so you're not going to see as many of these, but I know these pop up on SATs pretty often. So what kind of figures do you see? So I see a square and I see 4 circles stuck inside that square. So if I have the shaded area, I can find the outside figure, no problem. That's just a square. So I'm going to state area of the square. So if that's a square, then I know area is just length times width, or 12 times 12. So that's 144. And they did give us units, so meters squared. And then what would I have to take away from the area of the square to just have the shaded part left over? I've got to take out those circles. So each one of those circles, I've got to figure out what piece for area. Well, again, go back to your formula page, excuse me, and the area of one of the circles is going to be pi r squared. So as soon as we know the radius, we can find the area. So we just need one radius, one little piece. Any ideas? Well, let's see. We have 1, 2, 3, 4 of those radiuses go straight across the figure and would be equal to the 12. So if I divide that 12 up into 4 equal pieces, then that means each one's going to have to be 3. And that's the other reason I know this is a square, because if I went in the other direction, let me change colors. So over to purple. So if I did the radii in this length, they're still the same circles, they're still the same radii, but going in the other direction, that kind of gets me back up to that 12. That's just verification that I know this is a square. Alrighty, so one circle is going to be pi times 3 squared, otherwise known as 9 pi. And I'm actually going to go ahead and leave that in terms of pi just for the moment. So that means all 4 circles. What do I have to do with that 9 pi? Need to multiply it by 4. So 4 times 9 pi. And I'm treating pi just like any other variable, like an x or anything else. 4 times 9 gives me 36. So this is 36 pi. So all 4 circles come to 36 pi. The square comes to 144. So to do just the shaded area, what operation should we do between those two values? We need to subtract. So that means shaded area equals the square minus the circles. So the square was 144. The circles were 36 pi. And if the problem said leave answers in terms of pi, this is how I would write it. However, if the problem said leave your answer like rounded to the nearest hundredth, then I would take this whole expression, 144 minus 36 pi, and plug it straight into my calculator. So if you're doing this on Desmos, again, there's a little pi button that you could use. If you're using a graphing calculator, TI graphing calculator, look for that little up arrow, the caret button right above the division sign. Right above that is pi, and that's an exact value of pi. And I would always suggest using that value when you're doing your calculations. So if I plug that straight in, and I would double check this on your own to make sure that you can get the same number out, I'm getting approximately 30.90. My units are still meters squared. And so that's just the shaded area left over when I take out the circles.